This video is going to help you with learning target 1.4, how to describe relationships among wave speed, frequency, and wavelength of mechanical waves using arrow math. This is going to help you with CFA Common Form Assessment number 3. So let's just start with the big picture. You basically are going to end up with only two possible answers for this assessment. Either you're going to find out that two of the variables are inversely proportional or they're directly proportional. So you need to know what these two words mean. If you don't know what these two words mean, then there's no way you're going to pass the assessment. So here's how you can know them. Inversely sounds like reverse. Inversely, reversely, opposite. Inversely is opposite. So basically, when you have something that looks like this, where the two variables go in opposite directions, here one frequency is going up and wavelength is going down, opposite directions, these are reversed, or these are inversely proportional, because higher frequency means you're going to have lower wavelength. Reverse, inverse. All right, now directly proportional means they're going to go in the same direction. There's two basic possibilities for this. Okay, for example, speed's going up, a wavelength will go up with it. Those are in the same direction, they're both going up. That would be directly proportional. Or you can have speed going down and one of these going down. Speed going down and frequency going down. These two are now directly proportional because they go in the same direction. Now notice how this always involves two of the variables. Two of the variables. Those are the two you're talking about, the ones that are changing. And either they are going opposite directions, which is reverse, inverse, or they go the same direction, which is same direction directly. All right. You're going to have to write it with a claim, evidence, and reasoning. So here's the short version for this. The claim is going to answer the question, and it's either going to be inversely or directly proportional. That's going to be your claim. But you normally do that part, think that part last, because you got to think through the evidence first. The evidence are what the numbers tell us. So the first thing you're going to do is go through the evidence and look at the numbers and see if they're going up or down. Then you're going to think about the numbers, which is your reasoning, because this is the because part. You're going to look at the numbers and think, is it inversely or directly? Because. Well, because. Why? Are they either same direction or reverse direction? So here's our first example. Trial A. Here's our numbers. First thing you want to look at, the first thing you should fill out is the evidence. Okay? So you want to look for numbers that are changing because those are the ones we're going to be comparing. Now I'm looking right away. I see frequency is 8 the whole time. So frequency is constant. It's not changing. So basically, I'm going to ignore frequency because it's not affecting these other two. So this is all about speed and wavelength because they're the ones that are changing. So first let's look at speed. Look at the numbers for speed for trial A, B, then C. What is happening to speed? The speed goes from what to what? It goes from 10 to 6. Okay? And then you just got to figure out, is it increasing or decreasing? Going from 10 to 6, increasing or decreasing? That is decreasing, is going down, getting smaller. Smaller, 10, 8, 6. All right, wavelength now. Wavelength goes from what to what? 1.25 to 0.75. That increasing or decreasing? Decreasing. They're getting smaller, so that's going down. So the evidence is first. You got the evidence filled out. You look at the numbers just to describe what they're doing. Okay, now we can think about the because part. We got to go through the logic and look at these arrows and figure out what our because is. So the reasoning is next. The reasoning. Well, just looking at these arrows, we know that speed and wavelength are blank proportional because they're both going in the blank direction. So look at their direction. This is how you think about it. You're actually thinking this way first. Which way are they going? Are they going in the same direction or opposite directions? They're going in the same direction because they're both going down. They're going in the same direction. So what does that tell us? Is it directly proportional or inversely proportional? Same direction means directly proportional. So that's our reasoning. And then you can actually write out the wave equation because you're going to have it on your yellow paper and then show this because this shows how it works out. So speed is decreasing, frequency is constant, and wavelength is going down. So the arrow math helps tell us and show us why they both go down together because left side is decreasing of the equation, so the right side has to be decreasing. All right, let's put it all together. So now we come to the claim. The claim is really the answer, but it's pretty short. It's one sentence, and it just answers the question. So let's look at our arrows. What did we come up with? Was it directly or inversely? Were they directly or inversely proportional? Look at the arrows. We already went through this. They're directly proportional because they're going in the same direction. So now don't just write it is directly proportional, or they are directly proportional, or the table is directly proportional, because really you're looking at these two variables. You have to write down the two variables you're talking about. And notice how we're not talking about frequency, because frequency is constant. We're talking about the other two variables. So what two words go in here? Speed and wavelength. This whole claim evidence reasoning is about speed and wavelength. Speed and wavelength are directly proportional. Now let's look at our entire answer put together. What was the evidence? Well, the evidence was speed went from 10 to 6, it's decreasing. Wavelength went from 1.25 to 0.75, it's decreasing. So how do we know that it's directly proportional? The reason we know it's that the speed and wavelength are directly proportional because they're both going in the same direction. And here's our arrow math to back it up. So here's our entire claim, evidence, and reasoning. And notice all over the place we have speed, wavelength, speed, wavelength, speed, wavelength. Everything in here is talking about speed and wavelength. So that right there will get you a 3 on the formative assessment. If you want to get a 4, write about the equation and how the arrow math shows that they are also directly proportional. That'll get you a 4. All right, let's try one more example to make sure you're getting this, because you have to be able to do both kinds of answers. So we're looking now, trial B. All right, remember we're looking at the numbers first. You want to write the evidence first. You just describe what's happening to the numbers. What I'm noticing right away is that one of these is not changing. So what's the one we're going to basically ignore because it's not changing? We are going to ignore wave speed, right? Because wave speed is staying 12 the entire time. It's constant. So this is not going to be basically not in any of our evidence because it's just staying constant. So we are going to look at frequency and wavelength. So the entire claim evidence reasoning is going to be about frequency and wavelength. So let's write out our evidence right away. What is frequency doing? Wave frequency goes from what to what? It goes from 6, 3, 2. It goes from 6 to 2. So is that increasing or decreasing? Decreasing, because that's going down. 6 to 2 is getting smaller. So this is decreasing down. Now, wavelength. What's wavelength doing? It goes from what to what? It goes from 2 to 6. So is this increasing or decreasing? This is increasing because it's getting bigger from 2 to 6. So that arrow is going to be up. So that's our evidence. We got the evidence done. Now we're going to go through the reasoning. So the reasoning, again, we don't care about wave speed, it's all about frequency and wavelength. So we know frequency and wavelength are something proportional because they are both going in the, well, this is the main thing we got to answer. What directions are they going in? Look at these two arrows. What direction are they going in? When you compare them, they're going in opposite directions or reverse directions. One's going up, one's going down. So what kind of proportional are they? If they're going reverse direction, what kind of proportionality are they? Reverse, inverse. They're inversely proportional. So this is our reasoning. Because they go in opposite directions, frequency and wavelength are inversely proportional. And again, you can go ahead and do the arrow math. Speed is constant like this. Frequency is going down. Wavelength is going up. And there's your reasoning. So to finish up, you can go back and write your claim now. So the claim, first, what are the two things that go in here, the two variables we're talking about? Frequency and wavelength. Don't just say they or it or the table. You got to say frequency and wavelength because these are the two arrows we're talking about. And then, what kind of proportionality were they? Inversely or directly? They're inversely proportional. So let's look at our entire answer. Okay, claim, evidence, and reasoning. So again, it's all about frequency and wavelength. Frequency and wavelength, frequency and wavelength. So this right here will get you a 3 on the CFA. If you want a 4, Write a sentence about the wave equation and say, the wave, as shown by the wave equation, it is showing that frequency and wavelength are inversely proportional. And that will get you a 4 on the CFA.